Welcome to Chapter 4, and this section is primarily on radian measure, although it's called radian in degrees. We're going to be working in both. Generally, as you're entering this course, you're a little more comfortable in radian or in degree measures, and hopefully you're at least as comfortable in radian measures as we exit this chapter. But 4.1 is a section that we just can't afford to be pretty good at. This is a section we have to master. You're going to get a lot of practice problems in here, and hopefully this ends up feeling like a whole lot of easy as we move on. So let's go back. I've got a couple crude circles drawn here, but let's go back to something that we all should be aware of. The circumference of a circle is 2 pi radians. 2 times pi times r. So I guess we need to talk about what a radian is. 1 radian is the measure of a central angle. Okay, so a radian is not part of the circumference. It's a measure of an angle that intercepts an arc, S we'll call it, and that for whatever reason S is used for arc lengths a lot, equal in length to the radius of the circle. Okay, so the radius of the circle is here, and I'm going to create an angle by rotating around this direction till I feel like this angle measure, or this arc length, excuse me, once this arc length seems like it's the same length, and that's pretty close, this arc length, that might be a little bit long, somewhere right around in here. So this angle measure theta, there's my arc length S, here's my radius, of course, R. If S equals R, if the length of this arc equals the length of this radius, then theta is 1 radian. And as I said, a little bit crude. Okay, in perspective of how this looks. So when we talk about this arc length, it's okay to say an arc length is just part of a circumference, or an arc length is a fraction of the circumference. What fraction of the circumference is it? Well, you're going to see down here that pi radians is 180 degrees. So 2 pi radians gets us around the circumference. So what fraction are we? The fraction we've rotated around here in terms of the angle measure is theta out of 2 pi. 2 pi would get us all the way around the circle. It's theta radians out of 2 pi radians. So take a look here. The 2 pi's cancel, and we get S equals theta times R. And then later on, for arc length, they're going to tell us that. S equals R times theta. That's because it's a fraction of the circumference. But if S equals theta times R, then theta, solving for theta, we would divide R on both sides. Theta equals S divided by R. So if this, I'll call it S1, equals R, we're dealing with 1 radian. If I've got an angle measure out here, or an arc that gets me around to here, a new angle measure, that's beyond 1 radian. That arc measure is beyond 1 radian, and therefore the angle around there is bigger than 1. And it's just the fraction. It's just the length of the arc divided by theta. If the length of the arc reaches theta, we've got 1 radian. Okay, so this thing could be understandable right here. Or maybe better to say this should be completely understandable right here. An arc length is a fraction, left it as a plain old empty fraction of the circumference. What fraction is it? Theta out of 2 pi. That gives us this formula. This in turn gives us this formula. Pi radians, since they probably should start this with pi radians equals 180 degrees, therefore pi radians divided by 12 inches. 12 inches. Pi radians, sorry, I was thinking ahead. Pi radians divided by 180 degrees is just 1. And 180 degrees divided by pi radians is 1. Now, much like 12 inches divided by 1 foot is just 1 unit. They're equal. 12 inches, 1 foot, equal. So there you have it for those first three. Now, linear and angular speed, we're going to come back and talk about those as necessary. They're going to make sense to you, but I want to get right into some of these first topics on this. Like I said, we're going to have a lot of problems, but should end up being a whole lot of easy. And to be perfectly honest, on the first page, numbers 11 and 12 may be the toughest ones on here. Estimate the angle to the nearest half radian. Okay, so we have an angle measure that's spinning this way. I'm going to just throw these axes in. And I know that by time it spins around to here, we've rotated 3.14 radians. This would be 1.57 radians if we rotate this direction. Now, some may suggest in the future as we rotate in this direction, a clockwise rotation from the x-axis is oftentimes considered negative. But we're just going to deal with that rotation, which is over 180 degrees. So rotating from here to here, half of 3.14, here's 3.14. If we went all the way to here, it would be 3.14 plus 1.57 more. So that would be 4.71. We stop somewhere right in here. So, well, not somewhere, but we stop exactly right here. So if this is 3.14, this is 4.71, about halfway between those two, what would we end up having? Let's just go ahead and clear this out. And we could always do this, 3.14 plus 4.71 equals, divided by 2, and we're at about 3.9 radians if we were halfway between, and we look like we're maybe a little bit more halfway between. So I'm going to say we're about 4 radians. That's about our rotation right in there. So, and a half radian is a fairly decent amount. If you think about this one, pi radians, it's 3.14 radians to get from here to here. So they're just about 60 degrees. It's like here's a radian, just about 60 degrees, but then we come up just a little bit short. So half a radian, if 1 radian is about 60 degrees, half a radian is about 30 degrees. So you got a pretty good gap in there to look at that. So anyway, those beginning ones, a little bit more challenging, but we'll work more with strict radian measures, and you'll catch on for sure. Determine the quadrant in which the angle lies. So to create angles, we start on the x-axis in the positive. And now I'm going to rotate 5, 6. Now this denominator is key to me. That means it takes 6 steps to get halfway around the circle. So it would be like this: 1, 2, 3, 4, 5, 6. It's just 6 steps, and we want 5 of those. 1, 2, 3, 4, 5. So we are over here, and the angle that we're dealing with is there. Now, as I mentioned above, a negative angle, and the solution guide might have this one up here listed as a negative, but I don't believe they do. They're just talking about that rotation, but this is directional. So now we're going to rotate clockwise from that position, but look at the denominator. That tells me how many tick marks I go to get halfway around the circle. I'm going to go just 3. 1, 2, 3 steps of 60 degrees. 1, 2, 3. But I have to continue 4, 5. 5 steps where 3 gets me halfway around the circle. 1, 2, 3, 4, 5. So here's my angle's going to end out here. Here's our angle, but our rotation is on the outside. Negative. Think of it this way. We start on the x-axis and we go down. Negative. Here we start by going up. Positive. Okay. "12 tick marks to get halfway around the circle." That means it takes 6 tick marks to get to here. 90 divided by 6, about 15 degrees. 1, 2, 3, 4, 5, 6. And I could continue around there, but I've gone far enough. -5 of those. 1, 2, 3, 4, 5. Here's our angle that we just created right there. Going in a negative direction takes 9 tick marks to get around to here. So that's a little tougher because it doesn't divide by 2 nicely, the 9. So it would be 1, 2, 3, 4. We get to about 4 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks to get to there. But we still have to go a little bit further. Oh, we still have to come back and answer quadrant. Sorry about that. Still have to go a little bit further. We've gone 9 of those to get here, but 4 of them is going to get me right back up into here. It takes 4.5 tick marks to get to the quadrant, so we're approximately right in there. Is that exactly correct? I doubt it, but it is definitely correct enough for me to know that we are in quadrant 2. Here we are in quadrant 4, quadrant 2. We end up in quadrant 1 after we tour a long ways backwards. And then people will get to these and they'll think, well, there's no pi there, so it can't be radians. Well, here's what you really ought to think. There's no degree symbol here, so we're not in degrees. We're in radians, much like this. There's no pi here. This isn't 4.71 pi or anything like this. This is just 4.7 radians. It's 4 radians, not 4 pi. So 3.5, when we don't have pi's attached, I'm not going to do it that tick mark way. I'm going to say this rotation around to here is 3.14, 1.57, half of it. If I rotate a little farther, I'm at, let's go all the way around to this quadrant, I'm at 4.71, 6.28, just a fraction of half of 3.14. Add these two together. So 3.5, I don't have to get the angle exactly correct, is somewhere between 3.14 and 4.71, closer to 3.14, but more importantly for this problem, it's in quadrant 3. And 2.25, if this is 3.14, 1.57, 2.25 is somewhere between 1.57 and 3.14 in quadrant 2. Okay, sketch them in standard position. We've kind of just been doing that. It takes 4 steps from here to get to there. This is 4/4 pi, so 1/4, 2/4, 3/4. We are right here, halfway into quadrant 2. 4/3. It takes 3 steps to get here. 1, 2, 3. And until we're comfortable dealing in radians, you can always do the 180 thing. 180 divided by 4 is 45. 3 steps of 45. 1, 2, 3. 180 divided by 3 is 60. 4 steps of 60. 1, 2, 3. Another step of 60 right there. Make certain you don't say that this angle is here. The angle is this one. It was positive 4/3 pi. We rotate counterclockwise. 11/6. 6 steps to here. 6 more steps to there. That would be 12 steps. And so if it takes 6 steps to get to here, it takes 3 to get from here to here. 1, 2, 3, 4, 5, 6. Our angle terminates right there. Started right here. But this isn't the angle we're talking about. We're talking about this big rotation. They say, oh, it doesn't matter. Oh, it matters. There's a big difference driving here to Chicago to the east versus driving here to Chicago by going to the west. It matters. Negative 2/3, rotating negative. Starting here, rotating this way. Takes 3 steps to get to here. It's 180 degrees divided by 3 steps of 60. We only want 2 of those steps, so we end up right here. And soon we're going to be talking about reference angles, and then the reference angle, this is just kind of a preview, is the shortest angle or the smallest angle to get to the x-axis. The reference angle, I'll call this theta prime. That's just a preview of where we're headed. Okay, just plain old 2, not 2 pi, just plain old 2, and that's where I say 3.14, 1.57. 2 radian rotation is beyond 1.57, short of 3.14. I'm just ballparking it, but it's closer to 1.57, so we're about in there. Okay, and negative 3 pi, this is on 1, so just 1 step backwards gets me all the way to here. 2 steps, 3 steps, we get all the way around 1 pi, 2 pi, 3 pi's backwards, and we end up here. So how do we represent that angle to show that it's not just from here to here? We just spiral around to there so the reader can see it. Okay, so after the notes, pretty quick page. I'm thinking hopefully 11 through 23 may take you, maybe 6 minutes or so. Please, let's make certain that we take it to heart that this is a section we cannot afford to be pretty good on. It's so foundational for pretty much what we do the rest of this semester. So let's completely excel at this one.